Good morning. Good morning. This is your Captain Shreyas, and it's time to start the CYQs, the current year questions, then the PYQs, because these questions are absolutely important and tricky, and sometimes students fail to complete the question because of some silly mistake, misreading, or some common mistakes which many kids do in these kind of questions. So it's time to buckle up, to gear up and wake up, everyone. Message your friends. Yes, call your friends, even if they are sleeping, and tell them that Capto, your Captain Shreyas, is live at 6 o'clock in the morning to teach, to guide you, to mentor you, just like Sir has been doing for the past 13 plus years. But yes, today it is in the morning because I want every single minute of your attention. I want every single minute that you are leaving free. I want to make sure that you are practicing and not letting it go waste. So it's time. Thank you for liking. If you have not done that yet, please do that. And good morning. Hi, Ibu, Akhil, Abhishek. Welcome, Tarun, TM, Ivarun, Suhail, Sabri, Nandana, AVG. Wow, Pritija. Nice to see all of you guys showing up in large numbers. It's time to begin. And if you have forgotten to subscribe, please subscribe to the Vedantu J English channel. And yes, the PDF will be available after the session is over, not now. After the session is over, give it some time. It will be there in the link. And you can even ask doubts on these questions. You can also create a quiz on these questions. So it's time to begin the class on units, dimensions, errors. CYQ challenge begins 6 o'clock in the morning. Just few days to go for your JEE Mains January attempt. Let's begin. The first question on your screen. Which of the following is true regarding the physical quantities? Okay, statement based question. Very common these days in JEE Mains. It takes some time to read it. That is where the negative of the statement is. Two physical quantities can have same dimension but different unit. Let's think. Can two physical quantities have dimensions as the same thing but units are different? Just imagine something having dimension m raised to 1 L cube T. Okay, something is there. Unit can be something else, something else, something else. One is SI unit, one is British foot pound second system, one is CGS system. So multiple units are possible, even if quantity is same, like meters per second for speed, physical quantity, kilometers per hour, centimeters per minute, whatever. So this is definitely true. The physical quantity may have a unit, but can be dimensionless. Is it possible that something has a unit but has no dimensions? Dimensionless means like this, or think of it as m raised to 0, L raised to 0, T raised to 0. Which are those quantities? They are basically your supplementary quantities angle, like angle and solid angle. This is your plane angle, this is your plane angle and solid angle. These things have units, like this is in radian, this is in steradian. These are units. Unit is there, but dimension is not there. So a physical quantity may have unit. Yes, radian, steradian, yes, definitely for angles. They are supplementary units, remember that, but they do not have dimensions. This is also perfectly fine. Okay. If 1 and 2 are correct, then there is no such option which says only 1 and 2. So naturally, it implies third should be correct. Did you understand the logic? That is how you are going to apply it in the examination. That is your trick. 1 and 2 being correct implies third has to be correct, because there is no way, oh, option A is there, only 1 and 2, my bad, my bad. If it was maybe 2 and 3, sorry, if it was 2 and 3, and then I don't have to check 1, because there is no such option like 2 and 3. If 2 and 3 is correct, then 1 is correct. All right. 1 and 2 option is there. I didn't see that. My bad. A physical quantity with a dimension must have unit. If there is some dimension like this guy, It has to have some unit. It is obvious. So hence all the three are correct. Option D. Very good. Yes. Yes. But you got my logic. Very good. Awesome. Awesome. Is that clear? If somebody would have checked second and third, then that person will not check the first option because 2 and 3 is only there in D option, no other option. Right. These are your statement kind of questions. Let's begin with the next question coming up on your screen. Let force be A sin ct plus B cos dx, where x and t are displacements and time. The dimensions of C divided by D are same as which other dimension? Some equation is given, some constants are there which have some dimension. X is displacement, T is time, and question is dimension of C divided by D. Now, whenever you get logarithmic or exponential or trigonometric, these kind of expressions always are dimensionless. Even so, whatever is there inside the parenthesis and even the quantity as a whole. What do I mean by it? Example, if I say sine of something, if I say sine of something, cos of something, log of something, exponent of something, then this quantity which is there inside should be dimensionless, and this whole quantity, this entire thing, the dimension of sine is also nothing. It is also dimensionless. So inside and outside both are always dimensionless. Keep that in your head. Sine, cos, tan, e raised to something, log of something, ln something, all these functions, exponential, trigonometric. So look at these two terms, you will immediately get the idea. Look at these two terms, you will immediately get the idea. CT should be dimensionless. C into T should be basically dimensionless. Even so, the D into what is that? X should be dimensionless. Now we will just divide both of them because C by D is asked. So dimension of C divided by D is the into dimension of T divided by X is another dimensionless entity. Therefore, the dimension of C divided by D, take that on the other side, will be dimension of x divided by t. X is displacement, so it is length. T is time, so it is t. So L by t. What is L by t? Whose dimension is it? Isn't it velocity? Isn't this like meters per second? Meters per second in unit. In unit, L is meters, T is seconds. So it is like velocity is measured in meters per second. So that's it. You will just mark velocity B as the answer. Very good. Karthik, Sohail, Harini, awesome. Anto, Krishna, very good, very good. God thinker, Devi, Nanda, awesome, awesome. Sohail, awesome, very good. Keep answering. Velocity gradient is basically the rate of change of velocity with respect to distance. So if you ask me what are the dimensions of these quantities, well, this is angular velocity. Come on, guys, think and tell me. This is how you can solve the questions. Don't just solve it for that time, but also introspect, analyze the question that you have solved. Angular velocity, omega is theta divided by time. So dimensionally speaking, it will be theta has no dimensions, only time has dimensions. So it will be basically t raised to minus 1. Isn't it? T raised to minus 1. Velocity, we just did it. Angular momentum, L, will be mass into velocity into distance. So dimensional formula will be mass is kg. So m raised to 1 meter per second into meter. So meter is there two times. So length raised to 2, and per second, guys, per second. So t raised to basically minus 1. M raised to 1, L raised to 2 into basically the what do you say? T raised to minus 1 from velocity side. Velocity gradient, that is basically velocity per distance, change in velocity per distance actually. It is change in velocity per distance. So velocity is there on the top. That means L raised to 1, T raised to minus 1 for velocity. Distance is just L raised to 1. So L raised to 1, L raised to 1 will cancel and I'm left with T raised to minus 1. So velocity gradient and angular velocity, they are coincidentally having same dimension. So you can also see two physical quantities can have same dimension, but they can be completely different in meaning. Angular velocity means completely different thing. Velocity gradient means completely different thing. Getting my point? Yeah? Awesome. So this is how the questions can come. You should always go beyond that particular question. Look at the options, introspect what other things can be asked. Here comes the next one. Force is acting on a body whose density is d, and their density and the force are related by some equation. It doesn't matter. It's a dimensional question. How are forces related to density? That is not our concern. That is not our job. Okay, it is there means there. Okay. The dimension of y is what? All right. Y is some quantity over here. And if I want to find y, the first thing that we should think of probably is shift this guy with the force. So therefore, my y will be the force multiplied by root of the density. Okay. So if I want to find the dimensions of y, if I want to find the dimensions of y, I will have to take the dimension of force and the dimension of density, the whole thing raised to half. What is the dimension of force? It is mass into acceleration. Acceleration is L raised to 1, T raised to minus 2. Density is mass per volume. So again, it is M raised to 1. Volume is L cube, but in the denominator, and this whole thing raised to half. Now you will combine the mass terms and everything together. So m raised to 1 and m raised to half will be together. So m raised to 1 plus half, 1, and this 1 half will be there here. Then length raised to 1 is there, and this is minus 3 by 2. Okay. Time raised to negative 2 is there, and here there is no question only of time, so just keep it as it is. Is that right? Okay, many of you have already marked the answer. Let's see what will it be. M1 plus half is 3 by 2. L1 minus 1.5 is minus 0.5. So L raised to minus half and T raised to minus 2. M3 2, okay, is here and here. L raised to minus half, it's only in option 1, and T raised to minus 2. So it should be option A, which is absolutely correct. Very good. Very good. Very good, Amrit. Naveen. Very good, Rajeshwari. Awesome, Sabri Krishna. Very good. Akhil. Awesome. Awesome, Smrit. Very nice. Very nice, Parmeshwar. Very good, Ibu. Awesomeness. Okay, moving on to the next question on your screen. Here it comes on dimensions. Lot of times JEE Mains has been asking just questions on dimensions. All fresh questions for you. Sigma and B are Stephen constants and Wien's constants. So they sometimes combine it with some other chapter. So just because it's units and dimensions doesn't mean it cannot be related to other chapter. And if you do not know heat transfer, then you will be stuck, because these numbers are coming from heat transfer chapter of 11th standard. Then the dimensions of sigma multiplied by B is what? Okay, first of all, let's try to recollect the formula for sigma and B separately, and then we will go to the answer. Okay, sigma. Sigma is coming in your Stephen's law, Stephen's constant. So you have basically energy which is generated per unit time. Emissive power is nothing but E sigma A T raised to 4. That is the formula. This is power. Power is work per unit time or energy per unit time. So dimensions of energy is M raised to 1, L raised to 2, T raised to minus 2. Is that right? M raised to 1, L raised to 2, T raised to negative 2. That is the dimensional formula for energy. So divided by time, that will give me power. Divided by time, that will give me power. Mass into acceleration into displacement. That is what is work or energy, because work is force into displacement. So force was m raised to 1, L raised to 1, T raised to minus 2. If you multiply it with one more length, which is displacement, you get energy. So energy per unit time, this is nothing but your power, power, which is nothing but energy, which is nothing but energy per unit time. So that is the concept I have used. Sigma dimensions, I do not know. That's what I need to figure out. That is area, so L raised to 2, and temperature, that is basically Kelvin, so Kelvin raised to 4. So from this, I am getting sigma is equal to, okay, this time just got, I mean, it will go on the top, it will become minus 3. So m raised to 1, L raised to 2, T raised to minus 3. This goes on the other side, or rather, I can say that this just got cancelled here and here. So this will also not be needed. This will also not be needed over here. And over here, this will be T raised to minus 3. Kelvin will go on the other side and it will become Kelvin raised to negative 4. Is that clear? This is the dimensional formula for sigma, everyone. This will be the dimensional formula for sigma. M T raised to minus 3, Kelvin raised to minus 4. Now let's look at the dimensional formula for, who is that? B. For that, we will remember the formula. Wien's displacement law, lambda max is Wien's displacement constant into the temperature in Kelvin. So dimensionally speaking, wavelength is nothing but in meters. So length, dimensional formula of B I do not know. Temperature is Kelvin, so I'll put K. So therefore, the dimensional formula of B must be L raised to 1, K raised to minus 1. K goes on the other side. Now we just have to multiply these two. So we'll just multiply both of them and see what do we get. So sigma into B dimensionally, if I multiply, first, sigma is this whole thing, m1 t raised to minus 3, m1 t raised to minus 3, Kelvin raised to minus 4. That is the first term. And here, L1 k raised to minus 1. Here, L1 k raised to minus 1. Let's see what do we get. M raised to 1, then length raised to 1, then time raised to minus 3, k raised to minus 5. Wow, some crazy dimension. Who is matching? Who is matching, guys? Come on. L1, M1, t raised to minus 3, k raised to minus 5. I think some misprint is there. Just check it out. Unless we have made a mistake somewhere. Did we make any mistake somewhere? Just check out. This was fine only, right? B, L, K. Yo, guys. Some, yes, we made a mistake over here. So sorry. See, sometimes what happens when you suddenly wake up in the morning, no? All these problems can happen. My bad, guys. I made it proportional. I'm so sorry. Wien's displacement formula, Wien's displacement formula was lambda max multiplied by temperature. Lambda max multiplied by temperature. Yes, B is lambda max into temperature, and the dimensional formula of B will be nothing but lambda max is meters, so length, temperature is Kelvin. That's it. So now I can use it directly over here. I can use it directly over here, which is L into K, which is L into K. And now we will start getting it. M raised to 1, then L raised to 1, then T raised to minus 3, K raised to minus 3. T raised to minus 3, K raised to minus 3, L raised to 1, M raised to 1. That is the D option. Yes, there you go. There you go. D option. Yeah, there you go. Very good. Very good. Many of you got it. Awesome. So remember, B was lambda max into the temperature. So these kind of things, I'm also keeping it because you should know what kind of mistakes you might do in the examination. This is how your mind might think. And I'm also human. And suddenly when you wake up in the morning and suddenly when you start studying, you also are thinking, what is happening? Why am I getting it wrong sometimes? or why am I making this kind of mistakes in the examination? Forget morning, in the examination. So sometimes what you need to do, okay, if option is not matching, don't get scared. Just go back and see, redo the problem. That's what I did. I redid. So that is very, very important. Or else trying to find a mistake, you will lose more time than had you just started doing it again, wherever you would have made mistake. Yeah. Moving on to the next one coming up on your screen. Wow, we have correct significant figures question. Distance is 3.30. The particle moves in 2 seconds. Then the average speed in the correct significant figures. See, calculation wise, there is nothing great in the problem. But what is important is the significant figures concept. The average velocity will be the distance covered, displacement covered, divided by the time. Displacement or distance, whatever it is, 3.30. Time is basically 2.0. Numerically, 3.3 divided by 2, 33 by 2, 32 by 2, 16. So this will be 1.65 meters per second. But do not mark A. Do not mark A. Be careful. I will have to count the significant figures. In this particular number, there are three significant figures. 1, 2, and this 0 also. Here, there are two significant figures. This is the minimum significant figures. Out of 3 and 2, 2 is smaller. So the final answer must have only two significant places. Only two allowed. But as you can see, there are three significant figures. So I will have to round it off. Round off to the minimum two significant figures. If this was 3 and 1, I will round it off to 1. If this was 5 and 6, then I will round it off to 5 significant figures. So that's how significant figures works during multiplication and division. Okay. So will I write 1.6? Well, the number is ending with 5. When the number ends with 5, then check the previous digit. If the previous digit is even, keep it as it is. If it is odd, then add 1 to it and make it even. Since it is even, I don't have to do anything to it. So it will be just 1.6 meters per second. So that is option D. How many of you wrote 1.65? How many of you wrote 1.7? Yeah, many of you got it wrong. It will not be rounded off to the higher number or lower number randomly. Okay, because 1.65 is close to 1.6 also and 1.7 also equally. Yeah, it is exactly in between. 65 is between 70 and 60. But will you make it 70 or will you make it 60? You'll make it 60 because the previous digit is 6. If it was 1 point, example, 35, then 3 is an odd number. So you can't put it as 1.3, add one digit to it and make it 4. So basically make it even. So 1.35 will become 1.4 because that number 3 is odd number. If it was even, just don't touch it, leave it as it is. Got it? So that is the catch in this problem. Let's go to the next one. Initial and final temperatures of water are recorded as this much and this much Celsius. Initial and final. Rise in the temperature is asked, meaning initial and final. So if I put final first and then initial, then I can write how much is the change in the temperature, which is always final minus initial. Okay, so this is what I will do. So I'll put final and then I'll put initial and then change in the temperature is final minus initial. So final is basically 82.3 plus or minus 0.3. Initial temperature is 38.6 plus or minus 0.2. So when I subtract, plus and minus will come. This is the absolute error. 82.3 minus 38.6. 82.3 minus 38.6. Come on, guys. How much is it going to come out to be? 13 minus 6, 7. Come on, everyone. Yes. How much is it coming out to be? Very good. Very good. Yes. 43.7. 43.7. Awesome. Awesome, 43.7. Now do not subtract this. 43.7 is there everywhere. Lot of people are going to mark this. Sir, 3 minus 2 is 1. So 0.1, sir. Wrong. Always add this even if you're subtracting. Yes, so this will actually become 0.5. So this has to be added. This has to be subtracted. Whether it is addition, whether it is subtraction, always the errors are getting added. Keep that in mind. So, hence the answer is option D. Many students make a mistake and these kind of questions can suck away your marks. Yeah, it will give you negative marks then. Be careful. Moving on. Next question on your screen. Get ready, guys. Very good. Many of you got it. Option D. Yes, correcto. Amazing. The formula for some random quantity is something. The percentage errors are this. Then the percentage error. Standard question. I'm doing it every class because not because it is difficult, but because this comes. It's just sometimes when I'm leaking the question, I don't think, okay, whether it is easy question or difficult question. I know it is going to come, means it is going to come. So I will do it irrespective of whether it is difficult or average question. So in such things, the error in that main physical quantity will be relative error of each quantity, relative error of each quantity multiplied by the powers of each quantity over here, like 3, y's power is 1 and z's power is 2. Always take the positive powers. Now if you ask me, the percentage error in x is 0.6, so I'll put 0.6 percentage wise over here. Percentage error in y is 3%, so just put 3% here. And then percentage error in z is 1.3, so put 1.3 over here. So I will get the percentage error in that final quantity. So 3 into 0.6, so that is 1.8% plus 3% plus 2 into 1.3, that is 2.6%. Come on, my dear warriors, how much is it coming out to be? Yeah, come on. How much is it coming out to be? Very good. Many of you have got it correctly. Very nice. 3, 2.6 and 1.8, guys. Yeah, 7.4%. 18, 30, 26, 74. Yes, perfect. 7.4%. Yes, that is the D option. Amazing. Amazing, Nanda. Amazing, Smriti. Parmeshwar, Harni, very good, Sabri. Anto, average, Akil, Nish, Sohel, very good, Ibu. Very good, Sai. Very good, very good. D option is the absolute right answer. Very nice. Let's move on to the next question. And here it comes. This is very tricky question, I feel. Kinetic energy formula everybody knows is momentum square divided by 2 multiplied by the mass. If momentum increases by 0.3% and mass is also increasing by 0.1%, then the kinetic energy will increase or decrease by how much percentage? Again, kinetic energy formula is given. So if you ask me relative change in the kinetic energy in the percentage form, it will be the percentage change in the momentum. Then you also have the percentage change in the mass, but the power of mass is 1. So I will multiply nothing with it. I'll put 1 into percentage, sorry, power of momentum is 2. So I'll put the number 2 in it. Now what I have seen that we should do over here is momentum is changing by how much percent? 0.3%. So I'll put 0.3% over here. Lastly, mass is changing by 0.1%. So I'm just going to put 0.1% over here. Now, if you do the math, 2 into 0.3 is 0.6 plus 0.1, that's 0.7. So a lot of people are going to say 0.7%, and sir, momentum increase, this increase, so this will also increase, and they will mark B as the answer. That is the wrong answer. You will get negative one. That's why you are waking up with me. Shreyas Sir is saving your marks. You don't attend Shreyas Sir's class, no issues. You will lose marks. You attend my class, you will make mistakes. You will be like, oh my God, what did I do? Sir, I'm getting wrong questions. I'm getting wrong answers. That is where you will improve. See, read the question again. It is a tricky question, like I said. Nobody is going to come in the exam and tell you it is tricky. You have to only identify. What happens over here is P square divided by 2m. If momentum increases, okay, because momentum increases, kinetic energy will increase. But when mass increases, denominator increases, kinetic energy will decrease. So, in this formula, the change in the mass is not increasing the kinetic energy, rather, it is decreasing it. Rather, it is decreasing the kinetic energy. Did you get this concept? Because it is in the denominator. So anything in the numerator will increase. If it increases, denominator increases, the ratio will decrease. So this point 1 is not contributing in the increase of kinetic energy. Rather, it is contributing in the decrease of the kinetic energy. That's why minus. And hence, the answer will be whatever this is 0.6 minus 0.1%. The answer came out to be positive. So this is 0.5%. And only because it is positive, it means it has increased. If the, let's say, this number was zero point 0.8, example, mass increased by 0.8, then the answer would be minus 0.2. That would mean the kinetic energy has decreased by 0.2 percentage. So here it should be increases by 0.5%. Loved the question? I think today I have saved many marks of yours. There were a couple of questions where many kids had made some mistakes. So if you have made those mistakes, I'm really proud of you because you are saved. Yeah. In the real competition, nobody should make the mistake. Here, you fall down, you get 0 marks, you get negative 100 also, I don't care. But you should be learning. In an experiment, focal length, least count is the least counts of the measuring scales of u and v are delta u and delta v, then the error in the measurement of the focal length of the lens. See, focal length can be measured if you know object distance and image distance using the formula 1 by f is equal to 1 by u plus 1 by v. But when measuring the distance of the object and distance of the image, see that scale will also have some error, a least count, and that error is delta u and delta v. So if this has error, then even this has error, obviously. So the question is only that how much error will be there in the focal length which you are measuring. Now this is a non-standard form. See, whenever, if imagine focal length was something like u raised to 2 into v raised to minus 3 or something, I know I can use delta u by u 2 times v, delta v by v 3 times, I can add them, I can get relative error and all of that. But here I am not allowed to do that. So we'll have to go from the basics, and whenever you get a non-standard formula. Example, resistors in parallel. This question has come. How many of you have seen that? Resistors in parallel, R1 has this much error, R2 has that much error. How much error is there in the equivalent parallel combination? Or capacitors in series? This also. Thank you guys for making it 100 live. Very good. Keep it up. I want to see the same N2. Alright. So, in such cases, use the concept of derivatives. Take f on the top, so it will become f raised to minus 1. U on the top, u raised to minus 1. V on the top, v raised to minus 1. Now take the derivative with respect to some variable. Doesn't matter what variable it is. Just take the derivative, guys. So it will be d by, let's say, dx. Some random variable is this derivative. But I can't take the derivative directly, as you can notice, right? So you'll have to use chain rule. So df raised to minus 1 by df into df by dx, chain rule, du raised to minus 1 by du into du by dx plus dv raised to minus 1 by dv, whatever variable is here, put it down, only then derivatives can be found easily, into dv by dx. Right, I've used chain rule, I've just differentiated here, and let's see what do we get. Okay, f raised to minus 1's derivative is minus 1, f raised to minus 2. Here we will be left with df by dx is equal to u raised to minus 1's derivative minus 1, u raised to minus 2 du by dx plus v raised to minus 1's derivative is n x raised to n minus 1 and dv by dx. Couple of things definitely get cancelled, like this minus 1, minus 1, minus 1. Dx, dx, dx. That's it. Okay, so what do we get now? We have f raised to minus 2, so I can make it as 1 by f square, and df is there. So basically, this will become df by f square is equal to, here we have du by u square, plus here we have dv divided by v square. So therefore, df will be f square, you multiply, here you have du by u square plus dv by v square. Now du is the error in u, dv is the error in v, df is the error in focal length. So I think there is a formula looking exactly like that, which is option B, of course. There you go, option B. How many of you wrote option B? Very good. RAS Gaming, Abhishek, Nish, Awesome Harni. Yeah. Uh, so this is one thing. Now over here, it was a lens, right? Okay, it was a lens. Now let me tell you, whether it is a lens or whether it is a mirror, the final answer will be the same. The point was, okay, I did not read whether it was a lens or a mirror. I know that these kind of questions, it will not matter. I'll tell you why. See, I'll tell you till where it matters and till where it doesn't matter. For example, let me put the sign over here. Now, let's say minus. Okay, example, we started off with minus sign. Then, oops, then this will be also minus. Okay, then this will be also minus. Okay, this will be also minus. Here also you will get minus sign. Here also you will get basically minus sign. Where is it? Here also you will get minus sign. Here also you will get minus sign. Here also you will get minus sign. Here also you can put minus sign, no issues with that. But remember, when we consider maximum error, maximum possible error, I mean, whenever error is asked, it is always maximum possible. There is no doubt about it. So then what happens when you write it as delta f? This f square will be there, and when you write this as delta u as an error quantity, this will be the maximum possible thing, and then you will see this will become plus, this will become delta v, and this will become v square. So even if there was a minus sign, you will still put it as a plus sign. Basically, you will try to maximize the error. Meaning, what do I mean by that? Maybe u is more, v is less. So, you have to compensate those extremities. Maybe u is also more, v is also more. Maybe u is less, v is more. Maybe u is less, v is also less. So all four possible options are there. Like one is large, one is small, one is large, one is large, one is small, one is small, one is small, one is large. All the options are there. And when such things happen, you have to consider, okay, maybe delta u is positive, delta v is negative. Delta u is positive, delta v is positive. Delta u is negative, delta v is negative. So when will you get the maximum magnitude of it? When you take the absolute value here, and you put a plus here. So that's when the error will become maximum. Are you getting this point? Yeah. Minimum error, if it is there, then it will be minus. Then the final step will have minus sign. In fact, this is the also reason why, say for example, some physical quantity is x raised to 2, y raised to minus 3. Why do you think delta p by p is 2 times the delta x by x plus 3 times delta y by y? And why is it not a negative 3? Why is that minus sign not coming? The reason why that minus sign is not coming is because we want the maximum possible error. Maximum possible error. That's why that minus sign is not coming. You always take the mod value. So if here also, actually speaking, this should have been minus 3. But we take the mod of it in delta y by y. So here also, whether it is minus sign or plus sign, lens or mirror, final answer will have that plus. That is very important. Got it? Yeah, come on. Let's go to the next question on your screen. And here it comes. Last 2-3 questions. A wire has some mass, some radius, and some length, the maximum percentage in the measurement of its density. Now, density is mass by volume. Since it's a wire, it will have some circular base, pi r square, and multiplied by length. So it will be mass raised to 1 into radius raised to minus 2, length raised to minus 1, whole thing divided by pi. So the maximum percentage error in density will be m's power is 1, so delta m by m. Then radius's power is negative 2, always take mod value, so delta r by r. Length's power is 1, so just keep it as it is, delta l by l. We are interested in the percentages. We are interested in the percentages. Okay, mass percentage. So delta m by m, delta m is 0.003 divided by mass is 0.3. To convert into percentage, multiply by 100. Okay, 2 times delta r is 0.005, whole thing divided by 0.5 multiplied by 100 to convert into percentage. Okay, oh sorry, plus, then length is what? 0.06 divided by 6 multiplied by 100 to convert it into percentage. Just check this out. What are you getting over here? Shift the two decimal places, and this will be just 1%. Then this will be 5 will cancel, just 2%, and that will be just again 1%. Yeah, so 1%, 2%, 1% is 4%. So 4% error, which is C option. Perfect. There you go. C percent, everybody got? Very nice. Amazing. Oh, amazing. Oh, amazing. Oh. Let's move to the next question on your screen. Yeah. Okay. If x is pi r into p square minus q square by 2, where p, q, r are some lengths, then this physical quantity must be what? Area, length, volume, velocity. Very straightforward. I don't think velocity will come because there is no time only in the equation. So how can it be velocity dimensionally? So if you look at it dimensionally, it will be dimensions of pi into dimension of r into the dimension of p square minus q square, p square minus q square into dimension of 1 by 2, right? That is what it will be. Pi is a dimensionless entity. R is dimension of length. P and Q both are length, so length square. And this is a dimensionless entity. So finally the dimension will be L cube, which is nothing but volume. Which is nothing but volume. Check it out. Option C. How many of you have spammed the answer C? Wow, very good. Amazing. Many of you have spammed the answer as C. Amazing, guys. Amazing, amazing, amazing. Very good. Now there is a last homework question. This is the dimension of what? But don't answer it here. Answer it in the comment section. Very simple question. Answer is there on the PDF slide. So you can download the entire PDF of today's class after some time with the solutions, everything, handwritten notes, everything will be there. And if you still haven't joined the Sigma batch where I am teaching plus my mentorship, plus amazing teachers like Paul sir, Diksha ma'am, Namrata ma'am, Pramod sir, with Ekalavya test series and the best quality content, high weightage topics, then please join it today itself. Time is running out. I don't want you to miss out this opportunity. Even if you have missed couple of classes, still there is a lot of things that you can learn. Okay. So thank you so much, guys. I hope you loved this session. And if you want more sessions like this, like, call more people, more energy will be there. How much fun it was when you saw so many answers coming in. I want everybody to come in huge numbers and attend these classes. Let's make January attempt our last attempt. Okay. January attempt, our last attempt. April, we are not going to give. We are going to get 99 percentile and we are only going to target JEE Advanced after that, right? That should be our aim. Bye-bye. Captain Shreyas signing off. Yeah, tomorrow morning we'll meet 6 o'clock. Tomorrow morning for electrostatics, we are going to meet.